All right, so this video is going to talk solely about categorical data. Categorical variables place individuals into one of several groups or categories. The values of a categorical variable are labels for the different categories. Red cars, black cars, blue cars, white cars. The distribution of a categorical variable lists the count or the percent of individuals who fall into each category. And notice when I use the car example, the cars would be the individual. So the distribution of a categorical variable lists the count or the percent of the individuals who fall into each category. Okay, so the radio station, the radio audience rating service Arbitron places U.S. radio stations into categories that describe the kinds of programs they broadcast. Here are two different tables showing the distribution of station formats in a recent year. So I've got all these different types of radio stations, or these, not radio stations, the different types of formats. And this is the count of the stations that are in each format, and this is the percent of the stations that are in each format. So I've got, it's a little fuzzy, it looks like 2,066 country stations. I've got 750 Spanish language. I've got 14.9% country. Okay, so the individuals here is not the format. It's what are these counts made up of, and they are made up of radio stations. So I'm going to look at each radio station, and I'm going to put them in a bucket based on their format. So the individuals are not the buckets themselves. It's not the categorical variable. It's what are you categorizing? That's what an individual is. The variable is how are you naming your buckets? Well, they are the formats or the types of programming. Okay, so I want to talk about the difference between a frequency table and a relative frequency table. So frequency table tells you how frequent something is. So I have 2,066 country stations. That's how many stations were country. That is their frequency. But it's 14.9% of the market. So that makes it relative. This is just a number. Now if I have 2,066 and there are only 3,000 stations total, that's huge. But I have 2,066 out of almost 14,000 stations. So the percent makes it relative. It helps you know kind of how it stacks up to everything else without having to look at all the other numbers to see kind of where it comes into play. A relative frequency table makes it relative to everything else. If I tell you there are 5 black cars in the parking lot, that doesn't tell you anything. Unless I tell you that, well, there are 10 cars total. Okay, well, so now I know that's half. So your brain already went to relative frequency. You already decided it was 50%. But if I tell you there are 5 black cars in the parking lot, and then I tell you that we're at the mall and there are 500 cars in the parking lot, that's a huge difference. So the count gives us good information, but the relative frequency table gives us relative information to all the other variables. This is why do the percents only add up to 99.9%? Well, to find these percents, you're taking these numbers and dividing it by the total number. And notice that they only went 1 decimal place. So there was some decimal chopping going on here, and it just didn't add up to 100%. It's not a big deal. Okay, that covers that. All right, so now let's talk about how you can represent categorical data. Okay, and I'm stressing the vocabulary because these are the words that I want you to use in your writing. This is what I'm going to be looking for on tests and quizzes. Columns of numbers take time to read. sometimes it's easier to make sense of data in a pie chart or a bar graph. Pie chart, bar graph, categorical data. Those are two ways to represent categorical data. Now, I can look at it in this chart that I have written all over, but that gives you the counts and the percents. But when you visually represent it in a bar graph or a pie chart, it's much more pleasing to the eye. It can get your point across much, much faster, and it's just pretty. Let's see. So let's talk about the bar graph. So the bar graph has to have a title. You have to have your X and your Y axis labeled. So these are all the different categories. This is my smallest number to my biggest number. Notice the bars do not touch because that's going to change in the next video. So for a bar graph, the bars do not touch. They will never, never touch for a bar graph. And then the height of the bars represent the counts, because that's what these are. These are the counts. They could have done the percentage if they wanted to, and then this would just go from 1 to 100%. But the bars represent for this one the count of the stations. And then we have this lovely pie chart over here that is beautiful and color coded and labeled, and it has this nice little key for all the colors, and that's really pretty. But I want you to think about making that from scratch is the biggest pain in the rear end. So pie charts are beautiful when they are presented to you, but they are a pain in the butt to make. The thing with pie charts, the only thing that can be kind of tricky with pie charts is that it has to include all the categories that make up the whole. So notice we have this other, because these are not all of the genres of music. So I have to have this other category that makes sure I get all the categories. If I said I wanted to go into the parking lot and look at all the trucks, and I said I'm going to look at Ford, Chevys, and Dodge. Well, that's great, and you could do that in a bar graph, but you cannot do that in a pie chart because these three brands of trucks are not the only trucks that are out there. So you would either have to have an other, or you would have to break down the other brands. So a pie chart must include all possible categories, and the way to get around that is to do the big ones and then have an other that make up a whole. Use a pie chart only when you want to emphasize each category's relation to the whole. So you cannot do a pie chart with a count, with a frequency. You have to do a pie chart with the percents, and that should make sense. If I tell you for adult contemporary there are 596 stations, well, how do you know how big to make the wedge for adult contemporary? So you'd have to turn that into percents before you can do a pie chart. And pie charts are awkward and very difficult to make by hand. I mean, drawing a perfect circle alone is ridiculous. Bar graphs represent each category as a bar. The bar heights show the category counts or percent. We talked about that. Could be a count or a percent. Bar graphs are easy to make and easy to read. Okay. Be careful. Okay, so let's look at this ad. This ad is for DIRECTV. It compares DIRECTV and the Dish Network and cable. And so let's look at this ad and let's talk about what's wrong with it. So it looks like a bar graph. So we have a bar here, and a bar here, and a bar here. And I can see the different heights, 56 to 81 to 95. Okay. Do you think that this would represent 56 and this would be 81 and that would make this 95? I mean, if I'm ballparking it, this jump is over 20 and this jump right here is 14. So it seems to be that the DIRECTV not only has made its bar, its picture, too tall, but the other thing that's making it so drastically out of proportion is the width. of this bar. So bar graphs compare several quantities by comparing the heights of bars that represent the quantities. Our eyes react to the area of the bars as well as their height. So when all the bars have the same width, the area varies in proportion to the difference in the height, and our eyes receive the correct impression. When you draw a bar graph, make your bars equally wide. But you'll see this example in advertising all over the place. Okay, who buys IMAX? And I know this is ridiculously hard for you to watch or for you to see in your notes, so just look up here. It says, when Apple Incorporated introduced the iMac, the company wanted to know whether the new computer was expanding Apple's market share. Was the iMac mainly being bought by previous Mac owners, which would not expand its market share, or was it being purchased by first-timers that used to own a regular PC and they're now switching over? To find out, Apple hired a firm to conduct a survey, and by the way, they hired a firm full of statisticians who get paid a lot of money to conduct a survey of 500 iMac customers. Each customer was categorized as a new computer purchaser, so haven't had one before in the past, a previous PC owner, which is a personal computer, so not a Mac, or they're a previous Mac owner. And the table summarizes the data. Okay, so let's look at the table first. So here are my counts. So these are the previous ownership. So this is people who had no computer before. So there are 85 of them, and that's 17% of the market, or of what the new iMac purchasers are doing. These are people who owned a PC. So there's 60 of them who have now bought an iMac, and that's 12%. And then here are the people who owned a Mac before, and that's 355, and that's 71% of the share of who's buying the new iMac. Total of 500 people, total's 100%. Okay, so 71% versus 12% and 17%. So absolutely, we've got repeat buyers going on here, because the 12 and the 17% are both very small pieces of this survey. Okay, but let's look at the pictograph here that's sort of trying to represent a bar graph, and let's look at this. So 12%, 17%, and 71%. This is counts. This is number. So we're looking at 60, 85, and 355. Now the heights look right. Absolutely. The heights look perfect. But look at the pictures. Like it said before, your eyes react to the size of the picture, and that Mac picture is so much wider than the little bitty Windows computer and the little bitty none. I haven't had a computer before, so it overemphasizes the fact that Macintosh new iMac buyers are previous Macintosh owners. So it seems like that's the point they're trying to get across. Okay, now let's look at the two bar graphs. So the two bar graphs down here, okay, now these are both based on percents. Okay, so think about what that is. That is a relative bar graph, because it's talking about the relative frequency, because they're percents. Okay. So I've got Mac up there at 71%. I've got none right there at, yeah, about 17%. That's about right. And that's at about 12%. Yeah, that looks solid. They're the same width. Absolutely. So now compare this to this. This still gets the point across, but this definitely overemphasizes it. Okay, let's look at the second one. So find me something that's wrong with this bar graph. I mean, look how little that guy is. Now, he's supposed to be 12%. Well, if we're starting at 10, yep, 12% would be just about down there. But doesn't that make previous PC owners look like a tiny, tiny, tiny percent of new iMac buyers? I mean, it's 12%. Like, that's over a tenth. That's 1 out of every 10 people have owned a PC before and are switching over to Macs. But this is trying to make it look super, super small, and it's because they're skipping the first 10. So it drops the low ones and makes them look just minuscule. And the Macintosh, yes, I mean, it dropped 10, but it's so tall, it just towers over. So this scale on the side, skipping the first 10, really emphasizes how small of a portion those two bars are. So, moral of the story, beware of the pictograph and watch the scales on the side. Now, start looking. Look in the newspaper, look in magazines, look on the internet, look at the news, and you can see when data is presented. The funny thing about stats is people say you can make the numbers say whatever you want, and they are exactly right. And I hope you learn that from this course. But start looking at things and look at scales and sizes and proportions and see, you know, what is the theme of the story? What are they trying to get across? And how do they present the data to the general public who don't know stats and don't know the correct way to present it so that they can use their representation of the data to get their point across. All right, two-way tables and marginal distributions. Okay. When a data set involves two categorical variables, we begin examining the counts or percents in various categories for one of the variables. A two-way table describes two categorical variables organizing counts according to a row variable and a column variable. A survey of over 4,000 randomly selected young adults, defined as 19 to 25, asked, what do you think the chances are that you will have much more than a middle class income at age 30? Okay, now let's look at the table. We've got young adults by gender and chance of getting rich. So I didn't just ask everybody their opinion, I categorized them by their gender. So you can see that in this table, I have these numbers, and then I have totals, and I have totals. Those are the totals for male and female, and these are the totals for what your opinion is. The yellow is the two-way table. It uses both variables. Okay, so let's look at this. Let's really make sure we understand this. If I look at what's green, if I look at the totals that are green, the 194, the 712, and all the way down, that is a marginal distribution. So if I say margin, you should think of a Word document or a Google Doc and changing your margins to try to make your paper go to 4 pages instead of just 3. Okay, so that's your frame of reference. So your margins are the sides of your paper. Okay, guys, the margins of a table are the sides of your table. Those are your margins. Okay, so all of the individual totals that are highlighted green is the marginal distribution of opinions. The marginal distributions that are highlighted blue is the marginal distribution for gender. The bottom corner is the total number of people who were surveyed. And the male and female, that's one variable. And the opinion of your chance of getting rich in green, that's the other variable. So this is a two-way table because it describes two categorical variables, gender and opinion about becoming rich. Opinion is the row variable, row, and gender is the column variable. So think like columns on a house. Okay, two-way tables and marginal distributions. The marginal distribution of one of the categorical variables in a two-way table of counts is the distribution of values of that variable among individuals described in the table. That's a mouthful. Okay, let's hold on a second. The marginal distribution of one of the categorical variables in a two-way table. Okay, so hold on. The marginal distribution, so let's do this one. The marginal distribution of a categorical variable, of one of the categorical variables. So what I've just boxed in red is the categorical variable of opinion. Okay, the marginal distribution of one of the categorical variables, so not both, just one of them, you pick one, in a two-way table, well, that's a two-way table, is the distribution of values of that variable, and that variable only, among individuals described by the table. So if I'm talking about a marginal distribution, I am only talking about the distribution of opinion, or I am only talking about the distribution of gender. So a marginal distribution isolates one of the variables in a two-way table, where a two-way table contains two variables. So this two-way table contains two variables, gender and opinion. And everything that's highlighted in yellow is the data that fits both of those variables. It's separated by both variables. The marginal distribution isolates one of the variables. So that's the green and the blue. Note, percents are often more informative than counts. We've talked about that, especially when comparing groups of different sizes. Absolutely. So if I have 300 females and 1,000 males, and I ask them their opinion about something, and I say 250 females said yes to that question, and 250 males said yes to that question. So if I just report this part, it looks like males and females believe the same thing, or the same amount of males and females believe the same thing, when that's not true. If I were to turn these into percents, I would see that females believe it much more than males do. So that's what that's saying. Make it relative. The distribution of opinion alone and gender alone are marginal distributions because they appear at the right hand and bottom margins of the two-way table. All right, I feel like we've kind of talked over and over and over this, so if it's still not clicking, pause it, go back, listen to all that again, because that's really, really important. Okay. To examine a marginal distribution, we're going to use the data in the table to calculate the marginal distribution in percents of the row or the column total. So, and then we're going to make a graph to display the marginal distribution. Okay, so here we go. We're talking about the same data. We've got males and females, and we got opinions. So percents are often more informative, so we're going to talk about percents. The first thing we're going to do is we're going to put them into percents. So it looks like I am isolating opinion here. So I'm going to do a marginal distribution for opinions, because this is taking just the opinion information out of this table. Okay, I'm turning them into percents. So what I'm doing is I'm taking 194 and I'm dividing it by the total number of people, and that gives me the percent of males and females. So we're taking gender out of this. that think they have almost no chance of being, I forgot what it was, something about financially successful by the time they were 30. So 4% of males and females feel like they have no chance. So I'm putting males and females in the same pool. I'm not looking at their opinions separately. That's why this is a marginal distribution. Then I'm doing the same thing for some chance and 50-50 and a good chance and almost certain. Okay, so now that I've turned them into percents, now I'm going to make, okay, think about what this is. What is this called? This is a bar graph. A bar graph that is labeled. It has an X and a Y axis. These are percents. It goes from 0 to 35 because I don't have any percents that are bigger than that. The bars are not touching. They are all labeled. They are all the same width, and they go up to the height that matches their percentage. So that is a bar graph for the marginal distribution of opinions. Okay, relationships between categorical variables. So marginal distributions tell us nothing about the relationship between the two variables. So we've isolated gender, and we've really isolated opinion and kind of analyze it. So now I want to talk about those two variables together, and that is called a conditional distribution because one variable depends on the other. Okay, a conditional distribution of a variable describes the values of that variable among individuals who have a specific value of another variable. So I'm looking at difference in opinion of all females. The specific value of the other variable would be females and then males. That's that other variable. The two-way table contains much more information than the two marginal distributions of opinion alone and gender alone. So what was green and what was blue? The yellow part in the middle says so much more. To describe a relationship between two categorical variables, we must calculate some well-chosen percents from the counts in the table. And I'm going to tell you that you have one of these on your test. Okay. To examine or compare conditional distributions. Number 1, select the rows or columns of interest. Use the data in the table to calculate the conditional distribution in percents of the rows and columns. Make a graph to display the conditional distribution. Use a side-by-side bar graph or a segmented bar graph to compare the two distributions. I'm a fan of the side-by-side. A segmented bar graph is really pretty. I think it looks like fruit stripe gum, but it's very difficult to make, and I think sometimes it's hard to actually read. So, big fan of the side-by-side bar graph, okay? So, but these are the two types of displays, graphical display, that you can use to compare conditional distribution. So that's stuff in the table in the middle that was yellow. Okay, now this is all beautiful and done for us, and we're going to just talk through it. But when we work on the homework, you're going to have to create this out of thin air. So really, really focus. So at the top, I've got my table. It says calculate the conditional distribution of opinion among males. Examine the relationship between gender and opinion. Okay, so here's what I'm going to do. I'm going to sort this information, males and females, and their opinion. So I'm taking what we had highlighted in that table that was yellow on that previous screen, and those are the numbers that I'm interested in because that's the data from the two-way table, from the inside of the two-way table. That is your conditional distribution. Okay, so I'm going to take, and I don't know why they have flipped males and females, but they did. So males are now first. So 98 over total number of males, and that gave me the 4%. And then I'm going to compare it to females. 96 out of 2367, 4.1%. So guys, I can now see that it's about the same percentage of males and females who think they have almost no chance of, I don't know, being financially stable by the time they're 30. Okay, but look what happens when you get to some chance. Female's a little bit more optimistic there. 50-50 chance, almost identical. A good chance, males pull ahead. Almost certain, males are up by 4%. Now, you could draw all kinds of conclusions from this, but what I want you to right now to make sure is you understand where all these circled percentages, number one, why we're doing percentages and not counts, where all that information came from, because you're going to have to physically make the table. Okay, so this is the segmented bar graph, which I do not care for, but you may have a multiple choice problem where you have to read a segmented bar graph. So, like I said, it looks like fruit stripe gum. I've got males and females. It's labeled by opinion. This is the percent of the chance of being wealthy by age 30. So again, everything is labeled. Everything you give me has to be labeled. Then I've got the percents from 1 to 100%, or from 0 to 100%. Okay, now I've got these color coded, so it's kind of like that pie chart. It's a pain in the butt to make. So almost no chance. Again, remember they were both 4%, 4 and 4.1%. So you can see how those are both really, really close. But then we got to some chance. It was 11.6 versus 18. Now, what I don't like about the segmented bar graph is this, a different color. This distance right here is your 11.6. And this distance right here is your 18.0. But where it hits the side is the total of the first two. It does like a running total, and that's why at the end you can see they both hit 100%. So when I compare this, I am not comparing where the purple hits. I'm comparing how big each purple section is to each other. So again, I think these are really, really difficult, number one, to make, and number two, I think they're really difficult to read as well. Okay, then we have a beautiful side-by-side bar graph, which I'm a huge fan of. So this has got opinion on the bottom, chance of being wealthy. Here's my percent. Now notice, this is opinion on the bottom, and then each one gets a male and female bar. So now I can look at each opinion and compare females versus males. Females versus males. So it really emphasizes the difference in opinion by gender because I can just compare the heights of the bars. Now notice in between each opinion the bars are not touching, but the male and female bars are touching. So when you do a side-by-side bar graph, make sure, because you're going to practice this, and I'm telling you there's one on your test, make sure you're super, super clear with all of the labeling, changing it to percents, getting all of this stuff, and drawing your bar graph. Okay. Organizing a statistical problem. As you learn more about statistics, you will be asked to solve more complex problems. Here's a 4-step process you can follow. I don't necessarily need you to write, state, plan, do, conclude. I just need you to start thinking in terms of that because when you do an FRQ, that's what you're going to write. You're going to put your Captain Obvious hat on and you're going to state what is the question you're trying to answer. How are you going to go about answering that question? What statistical techniques, and again, nobody's interested in your opinion, does this problem call for? So you are looking for cold, hard data. Then you're going to do, once you've collected your data, you're going to make a graph or carry out needed calculations. And then when you're done, you're going to conclude. You're going to give a practical conclusion in the setting of a real world problem. And then this last slide is just sort of in this section. These are the kinds of things that we talked about. So just, pause it, take a second, read through those. I'm not going to read them to you. And it should be a nice little conclusion.